Year 4 and welcome back to Lesson 1 in Week 4. I hope you guys are keeping safe and enjoying the activities online.
Talk to your partner. How do you hear sounds? What sounds do you hear right now? And what responses do you have to the sounds and why? In one of your last activities, you were asked to draw a picture of your house and label where you can hear different noises. So, where do these noises come from? Well, sound is an energy and it's caused by vibrations, and these vibrations then create the sound waves.
Why can't we hear this alien scream in space? And have you ever wondered when you make a sound like ooh, how does the sound actually get into your ears? Watch what happens when the spaceship crashes on Earth. That's more like it. So why is it that we can hear the aliens scream now? Well, sounds are made from vibrations. We can't see vibrations, but if we did, they would look a little like this. Sounds are made when objects vibrate. Sound waves make the air around vibrate, and the vibrations enter your ear. You hear them as sounds. In space, there is nothing for the sound waves to travel on. That's why we couldn't hear the aliens scream.
Energy. Energy means the ability to do work or move an object with force. Sound moves the air or matter around us. Sound occurs when an object is vibrated by force. Have a look at the picture below. Vibration. For sound to be produced, an object or matter needs to be vibrated or moved by a force. Can you see the particles? These are showing the vibration and the air in between the particles. Sound waves. The initial vibration used to make a sound vibrates the matter, surrounding it in a chain reaction and creating the waves. How are these sounds different from each other? Sounds can have different pitches, frequencies, wavelengths and amplitudes. They sound different to our ears. Wavelength is the distance between two peaks. A higher pitched sound has a shorter wavelength. Low pitched sounds have longer wavelengths. Volume is proportional to the amplitude of the sound wave. Amplitude is the height of the wave measured from the peak to the trough. Higher amplitude, like the wave on the right, means higher volume. Lower amplitude, like the wave on the left, means lower volume. Talk to your partner. What unit do we measure sound in? Remember, you can pause the video and play when you're ready to find out the answer. Sound volume is measured in bells. We commonly measure sound audible to humans in decibels. Bells are named in honour of Alexander Graham Bell, who is credited for the invention of the telephone. Do you remember Alexander Graham Bell? The measurement of sound. Human ears can be damaged by sound louder than 85 decibels. Sometimes it is helpful to insulate sounds or make them quieter. Talk to your partner. In what situations would a sound insulator be helpful? It is also sometimes helpful to amplify sounds or to make them louder. Talk to your partner. In what situation would an amplifier be helpful? So, we might use sound insulators to reduce the sound. We can use foam, different materials, and often things which are very thick which can absorb the sound. Now we know that sound amplifiers increase the volume of the sound, so we might use sound amplifiers such as a microphone or a hearing aid. Sound frequency is measured in a unit called hertz. 10 hertz means that the 10 sound waves pass a given point in 1 second. Humans can normally hear sounds between 20 and 20,000 hertz. So how do we hear sounds? The vibrations caused by the initial object being vibrated reach our eardrums. Our eardrums, in conjunction with our nerves and brain, let us know that we are hearing a sound. Did you know that some dolphins and bats can hear frequencies up to 100,000 hertz? Ultrasound and infrasound waves. Ultrasound waves are waves with frequencies that are too high for the human to hear and shorter wavelengths than other sound waves. Infrasound waves are waves with frequencies too low for the human to hear. Ultrasound waves can reflect back more easily than other sound waves. They are useful in medical imaging, such as X-rays, non-destructive testing of mechanical equipment, medical uses and sonar. Infrared sound waves can record earthquakes that humans may not feel. Here are some sound scientists. Leonardo da Vinci is credited with finding that sound travels in waves. Galileo discovered the relationship between frequency and pitch. The aim of your experiment is to explain how sound is produced by vibrations. For this experiment, you will need a pan lid, a metal spoon, some rice, some cling film and a glass bowl. Step 1. Put cling film over the glass bowl. 2. Add rice on top of the cling film. 3. Hold the pan lid next to the bowl with the rice on top. After you've finished carrying out this experiment, I want you to see if you can write down why you think when you bang the spoon on the pan, the rice vibrates on the bowl. Thanks for watching, and remember to send your work through to Tapestry or Year 4 email.